Afternoon, maybe even evening. My name is Mr. Wagner. This is Algebra 2. Today's our last section of Chapter 6. We're going to be solving radical equations. Now, once again, when you're doing these, the focus is to isolate your variable term, right? In order to do that, you would subtract 1 from both sides. And once you're here, now you can undo your property. You're taking inverse operations to get to the point where that's your solution. And when you have quadratics, when you square root both sides, what happened here is it popped up two different answers. So when you square root a value, you have two different options what could potentially be the answer. The whole name game is to isolate your variables. But what happens here? Right, notice I want to get this all by itself. In order to do that, you need to isolate the term that has your variable. So flip this over there. You get this equals 4. Now there's two ways to go about thinking how this is going to be solved. Right? If you want to undo a cubed root, you need to cube both sides. Right, in order to execute that, the cubed root of x cubed is just x, and 4 cubed is 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is 64. Boom. Another way you could look at this is if I was right here, the cubed root of x is equivalent to x to the 1/3. Right, same thing. But if you want to get x to the 1/3 as x to the first, you would have to multiply it by 3. Right? 1/3 times 3 equals 1. And that's what you would do to both sides. Whatever you do to one side, do the same. These are the same process. Right? One has a root, the cubed root. One has an exponent of 1/3. Whatever makes sense to you is the right way to do it. Because here, we will be doing that operation. First things first, you want to get rid of your coefficient. You want to isolate just your x term. What you're left with is x to the 3/2 equals 250 divided by 2, which is 125. Now, two ways to go about this. If you want to get rid of 3/2, you want to take it to the power that would knock it back to 1. Right? 3/2 times 2/3 equals 1. That will cancel out that variable. Right? Powers of powers multiply. 3/2 times 2/3. Notice the 2's cancel out, the 3's cancel out. You're left with just 1. Boom. You're left with just x to the first, which is exactly what we want. That's equivalent to this. Now, simplifying this, there's multiple ways to do this. But what we're going to do is take it to 125 to the 1/3 squared. Right? You could break 2/3 into 1/3 times 2, because it's the same thing. That's what we just did. That's how we simplify these. You shrink it down and blow it up. Right? The cubed root of 125, what number times itself 3 times equals 125? Well, that's a nice number. That's just going to be 5. The cube root of 125 is 5, and 5 squared is 25. Notice this 2 up here stays there. The 2 becomes 25. This 3 goes here. The cube root of 125 gives you that 5 value. That's how we solve with power functions. Move on. Things are copied down. To solve radical equations, you need to eliminate the radicals or exponents. To do this, you must raise each power to each side of the equation the same power. Make sure the radical expression is isolated before raising the side the same power. This is essential. You can only take, if you want to cancel out powers, make them into 1, you have to take both sides to the same power. However, raising sides of both of an equation of the same power may produce extraneous solutions. You should always, always, always double check your solutions to verify that they are in fact solutions. This will pop up. This will also be in the test. You need to plug your work back in, because there's times where an answer that could have possibly worked proves not going to work. So let's start here. First things first, we need to isolate a radical, which this is what we want to isolate. We can get rid of it by squaring both sides. Before we do that, we need to subtract 2. Right, get rid of that 2. 5 minus 2 is 3. I'm left with root 4x minus 7 equals 3. I'm going to get rid of my square root by squaring both sides. What I'm left with is 4x minus 7 equals 3 squared 9. Right, notice when we're squaring a square root, it just cancels out. 3 squared is 9. 4x minus 7 equals 9. Add 7 to both sides. 4x equals 16. Divide by 4. X equals 4. Once you get right here, you need to plug this 4 back in to make sure this produces a correct answer. Because there will be times where we square rooting a negative value. That's not a good news. So, the way we check this, root 4 times 4 minus 7 plus 2 equals 5. 4 times 4 is 16. 16 minus 7 is 9. The square root of 9 is 3, and 3 plus 2 is 5. This checks out. Very nice. We move on. Solve this. Now, once you're stuck here, please note, if you have 2 radicals, with 2 radicals, put on opposite sides of the equation. If you ever get to the point where you're solving an equation with 2 radicals, you need to add this, flip it over, and then square both sides. What you'll be left with is root 3x plus 2 is equivalent to 2 root x. Because now I can square both sides. Square, square. Make sure you get everything, including that 2 in the square. Left side becomes 3x plus 2. Right side becomes 2 squared, which is 4, and root x squared, which is x. Right? 2 squared is 4. Root x squared is just x. Make sure to square both terms. Also, this is easy peasy. Subtract 3x from both sides. You get x equals 2. Let's make sure we're plugging this back in to check. So this becomes root 3 times 2 is 6. Root 8 minus 2 root 2 equals 0. That checks out because root 8 is 2 root 2. Which means they cancel out. Boom, we just checked our work. Very nice. Solve here. Now note here, make sure to square the entire left side. Because when you do this, it's ready to be squared. But you get to square the entire left side. What happens here is x plus 2 squared becomes x plus 2 times x plus 2. Don't just square x. Right side equals 2x plus 28, just like that. From here, distribute. What this turns into... x times x is x squared. X times 2 is plus 2x plus another 2x plus 4. Just like that. I'm going to combine these two. Get x squared plus 4x plus 4. At this point, combine all your terms. We'll be solving a quadratic. subtract 2x from here, and subtract 28. What we're going to get, x squared, 4x minus 2x is 2x. 4 minus 28 is minus 24 equals 0. What two numbers multiply to negative 24 to add to positive 2? That's going to be x plus 6 and x minus 4. Time to use ZPP. We get two solutions. X plus 6 is 0. X minus 4 is 0. X equals negative 6 comma positive 4. Now with both of these, run them back in. You have to double check. All the way up here. The reason being, check this out. When you plug in positive 4, it's negative 6 and positive 4. When you plug in positive 4 in here, you could take the square root of 2 times 4, which is 8. 8 plus 28 is 36. The square root of 36 equals 4 plus 2. That checks out. But when you plug in negative 6, look what happens. 2 times negative 6 equals negative 12. Negative 12 plus 28 is 16. The square root of 16 is 4. However, when you plug in negative 6 on the left-hand side, negative 6 plus 2 is negative 4. The square root of 16, when you plug in negative 6 for x, does not equal a negative value. This is where bad things happen. This is why we check for extraneous solutions. These are not equivalent. The root 16 is equal to positive 4, not negative 4. This is not a solution, extraneous solution. Only x equals 4. That's my answer. We move on. Solve this once again. We're squaring both sides, just like that. You get x minus 4 times x minus 4 equals the square root of root 2x squared equals just 2x. Left side becomes x squared minus 4x plus 4 times 4 is 16. Right, this comes from distribution. X squared minus 4x minus another 4x plus 16. These two middle terms become minus 8x. And from there, what happens here? Subtract 2x. What you get? X squared minus 10x plus 16 equals 0. What two numbers multiply to positive 16 to add up to negative 10? This is going to be x minus 8, x minus 2, because 2 times 8 is 16, and negative 8 plus negative 2 equals negative 10. ZPP, x minus 8 equals 0, and x minus 2 equals 0. X is equivalent to 2, 8. Check both of these to verify. You'll notice 8 works because you can do it. 8 minus 4 equals root 2 times 8. 8 will work because 4 equals the square root of 16. However, when you plug in 2, 2 times 2 is 4. 2 minus 4 is negative 2. The square root of 4 is not equal to negative 2. Wah, wah. 2 is not an answer. X only equals 8. X does not equal 2 because it's an extraneous solution. Thank you for coming by. Thank you. We'll learn very much.